Hello, my dear coders. So, once again, I am here to solve the LeetCode problem, and I am Aman with you to solve the LeetCode problem. So, yeah, today we are going to solve problem number 204, and the problem is count prime. So, the problem itself, we can see we have to identify the prime numbers, and after that, we have to count how many they are, and simply we have to return that count. Okay, so let's read the problem. What's the problem said? According to that, I am going to explain you the approach, the key idea, how we can implement the code for this. So yeah, here is the question. Like, given an integer n, return number of prime number that are strictly less than n. Like, we have to return the prime number up less than n number, means we are not taking that the last number up to n, only we have to identify the prime number and return how many they are. Okay, so before that I'm going to tell you what's the prime number exactly. So prime number is nothing but it's an number, or you can say it's an unique number, eh, that are start from 2 and goes up to n, and we are just taking those number only which are not divisible by any other number. It will be divisible by itself and one only. We are not taking as one that are divisibility. If suppose any other number which are divisible by more than one number, or the number which are divisible by any other number, so those kind of number not comes under prime numbers. Suppose, let's take one example. Suppose we are taking 3 and 4, two number. So let's check whether they are prime number or not. So if we can see, I'm typing here. Okay, so 3 means is divisible by 3 only. 3 divided by 3 only, it's give 0. Okay, suppose if we taken 4. Okay, 4 is divisible by 2 comma 4, so it's more than 1. So the number is divisible by other number like 2 only, 2, and 4 is itself. So it's not an prime number. It's not an prime number. Okay, I hope you all understand what's the prime number exactly. So yeah, let's see one example how we are calculating this thing. Okay, yeah, so in this example, suppose n equals to 10, we have returning that output is 4. Why? Because we have to just count how many number that's lying between 10, that's our prime number. So four prime numbers that are less than 10, and they are 2, 3, 5 and 7. They are divisible by itself only, that's why it's a prime number. It's not be divisible by any other number. So yeah, these are the prime number which are less than 10, and the output will be written as 4. Like how many they are, 1, 2, 3 and 4. So these are the 4 prime numbers that are lying between less than 10. Suppose if we take n equals to 0 and n equals to 1, it output should be 0 because the prime number is starting from 0 itself. So we are not taking that two numbers 0 and 1. So if n equals to 0 and n equals to 1, we have to simply return 0 as an output. I hope you all understand this question. Let's see if you are not understand. Let's see in my handwritten note. In that you can easily understand what the problem exactly say and how we are going to solve this. Okay. So yeah, here. Let's understand one more time what the problem is exactly. You have given an integer n, and you must count how many numbers they are prime and strictly less than n, like less than up to n we are not calculating, we are calculating less than n number prime which are lying between less than n. Okay, so here is the basic approach that we are taking. First, to find the number is prime or not. So suppose we are taking boolean as a function is prime, we are taking up to n number. Okay, iterating for loop in that I is starting from 2 and I into I will be less than n. Then we are and the next thing we are doing I plus plus, like moving to the next number is prime or not. So here we are checking that number modulo I is equals to 0. That's mean we are checking here is that number is divisible by any other number. If this condition is true, simply we have to return false for that number. That means the number is not a prime number. If the number is not satisfying this condition, that's mean we have to return true. It's mean it's an prime number. So yeah, next thing for this we have the time complexity is big of root n. That means it is too slow, and this approach will be considered for up to n equals to 5 into 10 raised to power 6. This means approx 5 million. You didn't get any time limit exceed up to this number. Okay, so for that resolving this kind of issue, we are applying another approach for this solving this count prime number with the help of Slep's method. In this, we are finding most efficient and elegant way to solve this problem. How we are solving this? Let's take an idea. So, first of all, we have create an Boolean array is prime, an array making as an array of size n, means up to size n. We have to make one array. Assume all numbers from 2 to n minus 1 are prime initially. It means we are initially take all the number which are lying between 2 to n minus 1 is prime. Starting from 2 and mark all multiplier of each prime as not prime. It's mean we are just doing one approach, like those number which are starting from 2 and they are multiplier of 2, we have to mark as not a prime number, and after that we have to count up to root n times, and next thing count number is still mark as prime, means up to n number we are marking that number are not in prime. Okay, so next thing, next that's in next page. uh, zoom out. So let's understand the logic what we are going to take here. So let's see step by step. Like first condition, if n is less than or equals to 2, we are simply n is less than equals to 2 means returning as 0. It's mean 0 and 1 we are not taking as a prime number here. Sorry, initially boolean we are taking one an array boolean size of n. Okay, set all entire entries to initially as in true, like we are taking all numbers as in prime number itself. In next approach we are just doing from p equals to 2 means prime equals to 2 to checking up to p into p means that number into number less than n. Okay, means up to that we are just simply doing marking the number which are divisible by 2 as a not prime. Okay, what I have written here, mark all multiplier of p from p into p to n as an false, means marking as a non-prime number. After that count all true values which are starting from 2, means one by one we are going to count how many numbers that are prime. lies between up to n number. Okay, let's see in the code part. I have already written in the platform. Let's see there what I have did and how we can write and code for that problem. So yeah, here is the code. Hmm. I hope you all can see in this. Okay, let's see this code, how I am implementing this and how this code is working. So as per the step-by-step logic, we had implement this code. So first of all, we have to check whether the number is less than equals to 2. Then simply we have to return false in that case. Like we are not taking prime number as 0. Okay. Next thing, we are initializing prime number that size is up to n number, like size of n array. Okay, after that one by one we are filling as an prime. If it is prime, simply we have to return true, like assuming all are prime initially, like filling initially all are prime. After that we are removing one by one, checking whether that number is prime or not. So one more thing is here, we are taking 0 and 1 as not an prime number because they are not lying as an prime. So we are just checking if prime is 0 and prime is 1, we are returning as an false. Okay, so now the next approach, we have to remove the multiplier as an not prime. For that we are writing this uh, for loop, I equals to 2 to I into I will be less than n and I plus plus. If prime I, if it is prime I, for that j equals to I into I, j will be less than n and j plus equals to I, means we are taking it from here, and is prime j equals to false, like multiplier of I we are removing that because multiplier of I it's mean they are divisible by any other number. For that we are that kind of number, like suppose 4 6 8, like that number we are removing from the array that are multiplier by any other number. 9 is multiplier of 3, so that's that kind of number we are removing one by one from this loop. After that we are initializing one count variable, in that we are uh, storing how many number that are prime. Okay, so here I equals to 2, I is less than n and I plus plus. In this we are not taking the last number, that is why we are taking I is less than n. Okay, what I am writing this comment. Okay, suppose if prime is I, then count plus plus. If the number is satisfies all the things, means if the number is not divisible by any other number and the number is not multiplier of any other number, that's mean we have to do count plus plus and take it as a prime number, and at the end we have to returning simply the count variable. Okay, I hope you all of you understand this problem in very easy way. In the bottom I have just explained what are the pseudocode we have taken for this. Okay, so yeah, this is the whole code for this. If you are not understanding this any kind of part, you can just comment below what you have not understand, I will make it clarify to you. So if you have any other doubt regarding this problem, just comment below, I'll solve it. Okay, so thank you for watching this video. And if you need any other questions of lead code problem, and if you're not understanding that part, you can just comment below. I'll solve it. I'm saying so many times, comment below means if you're not understand anything, just comment below. Thank you for watching this video.